So this is what the steam boiler looks like outside of that furnace. It is simply a refrigerator compressor, and the insides have all been emptied out. Unfortunately, the welder I have is I'm running a welder off a generator, and my generator is not sized properly to run the welder, and so my welds are horrible. It took me several days before I actually got the hang of it. I need to use the smallest size rod possible on maximum current, maximum everything, maximum hot start. And that's the only way. So this thing definitely has some water left over, and I let it sit there for several hours, and the fire burned down, so there's still heat coming off of the coals. And so some of the water did evaporate, but there's still some left, even after all that. So, let me show you the bolts that we have. There's essentially a really long bolt with a nut. The nut is welded onto the compressor, and right there where the nut is used to be the electrical connection for the induction motor on the inside, and I basically just punched it out with a hammer and like a punch tool, and then I kind of sanded down the edge so that the weld would stick, and I put a stainless steel nut. And of course you have regular mild steel and stainless steel, and it's not really a good match, but so far it's working. And I have a little tiny washer made out of aluminum, and it's pretty rudimentary, and it's pretty funky looking. It's definitely not the nicest thing. What this is actually somebody had a back, not a hood, what do you call that? A trunk from a car. Somebody had an aluminum bodied car, and they just dumped pieces of the body in the forest. And so this used to be part of a trunk, and I just cut it out and drilled it. I forgot how I got that exact size though, because I don't have... Oh, I used a Dremel. I used a Dremel to basically get the size this big, because I didn't have a drill bit that big. And basically, what we have here is a piece of tubing from a bicycle, and I tried to sand it down with the highest grit sandpaper I had and get it as flat as possible on both ends. And that is sitting on top of this washer. The washer's sitting there. This thing's sitting on here, and then on the other end, I have another washer. I have a bolt and another washer. So you put a washer on there. And the reason I did it this way is I wanted to actually drill a hole in this bolt and basically make an attachment where you could put a either the feed water or put a pressure gauge. And so I was going to basically, make a connection point. Oops, okay, yeah, that's what I wanted to do, is I wanted to measure how much water was left, but we spilled some on the ground. Oh well, we lost a good amount. And it's going to be pretty rusty, I think, from what it looks like. I was expecting that. Like, this boiler needs to be coated on the inside. So yeah, it's definitely very rusty, but there's a lot of water left. So even with how long we ran it for, it didn't use up all the water. So yeah, we still have at least a liter. We have probably a little over 1 liter left out of all that. So back to the little design here. So we have this washer, got the nut, put a washer, put this thing on top. Ideally I want the thicker side. It's not symmetrical. It's just a tubing from a bicycle. And then put another washer. And then the biggest bolt and nut that I could find. And that just literally just sits inside of there. And that's all that the boiler is. Oh, and I gotta show the where the steam actually comes out at, but okay, assuming I get it in the right order, right? If it's not in the right order, it's not gonna actually go together. But try that again. Okay, so that one is basically the outside one. This is way harder to do without a tripod. So, ideally I'd have a head-mounted camera. But, okay. Finally, got the damn thing. Basically this. This is all I'm using to contain the pressure and keep the water inside of this thing. So this is where I'm filling it at the moment, until we have the feed water pump built. I'm literally just doing it with the funnel. I really should let this air out, and just to reduce the amount of rust and corrosion. But, you know, for now. And then on the actual, the steam head, or the steam pipe, it's literally just a piece of a, you know, I have a bunch more of these things. I could show you what they look like. I used a torch to bend it because it didn't have, I wanted it to be a 90 degree, but originally it was like 60 degrees, and I had to heat this up with a torch and bend it up. But this is literally just a piece of a chandelier, and then on the inside is another piece of a mirror that has like a light ring, a ring light, and it has the same fitting. Almost all lamps that you get, they're made in China. They all have like this tin, I don't know, maybe not tin, but they all have the same exact size conduit, this metal conduit stuff. And I have also a little washer made of the same material. It's just a piece of aluminum from that trunk. And then this, that threads in. Now this is going to corrode. The fitting that's welded into this, though, this is stainless. So that should not corrode, at least not very quickly. And one thing else is that it doesn't go all the way down. It's like a L. It's like an L shape, so it has a right angle turn in it, and that kind of helps a little bit with keeping the water from, you know, droplets of water from, you know, bubbling out and splashing out. You know, it's obviously not a separator, but just having that little elbow kind of helps out. And it just happens to be that that's like the only piece I had that really was thick enough to do it, and so yeah, that's all it is. So I'm going to take this apart, and I'm going to go, before we run out of light, I'm going to show you the inside of that turbine, and then maybe tomorrow morning when we have more light, I will show you more up close, the whole thing, how it's all designed. So, till then, come on, phone.